Let's try to do this problem together. We're given this whole arrangement here with a whole bunch of capacitors at capacity 14 microfarads. There's a 10-volt battery here. We're asked to figure out what the charge is on capacitor 1 and capacitor 2 in here. Now, capacitor 1 is really easy because we know that C equals Q over V, and we're given, once we sort of arrange this, 0 volts starts here and 10 volts starts here. So we're going to add the 10 volts to this side, becomes 10 volts. This side becomes 0 volts. And so those things are connected. Over here, we could follow this and find 0 over here, but that's not connected. And over here, we have 10 volts connected here and 10 volts connected here, but these aren't connected. So we kind of have to figure out what the change voltage is throughout here before we can figure out what the charge is. But over here, we have C is already equal to 14 microfarads, which is equal to Q divided by the 10 volts. And so we can easily find by, Q is equal to 140 microcoulombs just by multiplying that out. Now for the second capacitor, it might be a little bit more difficult because we have to start breaking these things down into different sections. Let's try adding C2 and C3 together. And if we were to do that, we have to rearrange this a little bit. Okay, so we're going to combine these two into one. And because they are in series, then we have to say that 1 over CEQ is going to be equal to 1 over C2, which is going to be 14, plus 1 over C3, which is also 14. We'll change this to 23, C23, because that's what this is, C23, combination of that, which we figured out is going to be 1 over 7 microfarads, and so C23 is 7 microfarads. Now we can try to connect C23 and C4. Let's try to add the voltages in again. We know 10 volts is over here, 10 volts is over here. That's basically all. But if we add C2 and C23 and C4, then we'll come up with this new arrangement over here. And it's still 10 volts, and this is still 10 volts. But here's the cool thing. This is now C234, and we're just going to add those two together because C234 is going to be equal to 7 plus, and we know this one's already 14 microfarads. 7 plus 14 is going to be 21. So that's 21 microfarads. So from here, we can now try to split this up again, and we could try to combine these two together. Do that over here. So we basically just go like this and connect a big one. I'll call this C2345, and this is going to be 1 over that. So 1 over 21 plus 1 over, what's C5's again? It's 14 microfarads. 14 microfarads. And we add that together. 1 over 21 plus 1 over 14 becomes 5 over 42. And so when we take the reciprocal, 42 divided by 5, that's what the capacitance here is, 8.4 microfarads. And now, now we know that this is 10 volts and this is 0 volts. And we can figure out what the charge is here because C equals Q over V. And so when we multiply 10 volts on this side with our 8.4 microfarads, we'll get that the charge is going to be equal to 84 microcoulombs. And this is for this one. Now when we come back over here, we also know that when we reverse this, I'll write these equations over here kind of like C equals delta Q over V. This is for parallel. And then C equals delta, or sum of V over Q. It's actually 1 over C on these. 1 over C. So we know that this is 21 microfarads, and we know that the Q is also 84. Might be able to solve that because 21 microfarads is supposed to be equal to Q divided by the voltage. We know the Q is supposed to be 84 microcoulombs, so we can say that 84 divided by 21 is going to be equal to voltage, so voltage is 4. Voltage of this one is 4. And then the voltage of this one must be 6. Okay, great. So now we're getting somewhere. 6 volts, 4 volts. So we can say, I'm trying to figure out this one. So 7 microfarads is equal to the Q divided by the voltage. And we already know the voltage, I believe. That was supposed to be 4. Yeah, because these are going to have the same voltage, just different charges. So if we know that's going to be 4 volts, hey, this is going to be 6 volts right here then, right? And if that's 6 volts, now things might be starting to be a little bit better. Yeah, 6 volts, 6 volts. Okay, 0, 0 and 6, right? Because 0 and 6, you see how that works there. 0 and 6, and then we got 6 volts over here. That would be 10 volts. This got to be 4, and that's got to be 4. Good. We're getting somewhere. This right here was supposed to be 7, and then the volts is 4, so the charge is 28. 28 microcoulombs here. And then we'll work backwards to the initial with our 28 microcoulombs. Both of these have the same charge, so they're divided in series. If that's the case, I think we've already figured out that the capacitor 2 has a charge of 28 microcoulombs. That may be the answer.